Welcome once again to Simple Science. Today we are going to be solving Waec 2015 chemistry practical question, and it's actually question 1. It's a question on titration. It reads: A is 0.1 mole per dm cube of triazonitrate 5. B is a solution containing 2.50 grams of a mixture of sodium triazocarbonate 4 and sodium tetraoxosulfate 6 in 250 cm cube of solution. Put A into the burette and titrate it against 20 cm cube or 25 cm cube portion of B using methyl orange as indicator. Repeat the exercise to obtain consistent titers. Tabulate your burette readings and calculate the average volume of A used. The equation for the reaction involved in the titration is that you have, this is the equation of reaction. We have sodium triazocarbonate 4 plus triazonitrate 5 will give us sodium triazonitrate 5 salt plus water plus carbon dioxide. Then from your results and the information provided, calculate I, the concentration of B in mole per dm cube, II, concentration of sodium triazocarbonate 4 in B in grams per dm cube, then III, the percentage of sodium triazocarbonate 4 in the mixture. From the question, we have been given the molar mass of sodium triazocarbonate 4 to be 106 grams per mole. And so we'll get along. First thing to do is to write solution, and then, as usual, write the indicator used and the volume of the base. So from the question, we have that we should use methyl orange as the indicator, and so it is indicated. Then the volume of the base for this practical, we are assuming that we are using 25 cm cube portion of the base. So the volume of our base, that's VB, V subscript B, is 25 cm cube. And then another assumption is that we've actually done the titration, and then we have gotten different values for our rough, our first titration, our second titration, and the third titration. And then we want to see how we can use these values to solving and answering these questions correctly. So we have the table of values, and then we have them, we're going to use them. Now before we start solving, in course of carrying out this practical, your volume of acid used and the ones you should use to compute your average titer value should be within the range of plus or minus 0.1. That is the recommended tolerance. That the volume of acids that will be used to compute the average titer value or the average volume of acid used in the titration, they should be within the range of plus or minus 0.1 to enhance accuracy. So here we have that after the rough, we have 23.5, and then the first titration gave us 23.40. The second titration, we made use of 23.45 cm cube volume of acid, and for the third titration, we have 23.40. Now, how did we obtain the volume of acid used? The volume of acid used is obtained by subtracting the initial burette reading from the final burette reading. So you have final burette reading minus initial burette reading will give the volume of the acid used. The same thing too for the first titration, the second titration, the third titration. The volume of acid used in each case is obtained by subtracting the initial burette reading from the final burette reading. So you do final minus initial will give you this. Final burette reading minus initial burette reading will give the volume of acid. So that's how the volume of acid was obtained from the table. And then the next thing to take note is to get the average volume of acid used. And please, in trying to find the average volume of acid used, the volume of acid used in the rough titration is not to be used. Is not to be used. The ones to be used are the first, the second, and the third. So we say average volume of acid is equal to we have the first, second and third. So we have 23.4 plus 23.45 plus 23.4 divided by 3. We are looking for the average. You will notice that the average, the volume of acids that we are using to calculate our average titer value, they are all within the range of plus or minus 0.1. They are within that range. So this will give us 70.25 divided by 3, and when we do this, we will get 23.42 cm cube. This becomes our VA. That's the volume of acid. So let me write it over here so that we will remember it. VA equal to 23.42 cm cube. So we have this to be that, and then with this we'll go to the next thing in solving this. So the next thing we do is to balance the equation. I'm going to leave this information because we may need them as we get along. So the next thing to do is to balance the equation, that is if it is not balanced. So we look at balancing, that's the next step after getting the average titer value, balancing the equation of reaction. Balancing the equation of reaction. So we have Na2CO3 plus, we have HNO3, we have that it will yield NaNO3 plus H2O plus CO2. And don't forget that whenever an acid reacts with triazoocarbonate, carbon 4 oxide will be liberated, and so we have it to be like this. So we look forward to balancing this equation. On the reacting side we have this, and on the product side we have this. So on the reacting side we have 2 atoms of sodium here. Sodium is 2, and on the product side it is 1. So we put 2 in front here to make it 2. Now sodium is 2 here, but NO3 is 2 here. NO3 is 2. Yeah, NO3 is 1. And so we put 2 here to make it 2. And then we also see that hydrogen is 2 here. Here hydrogen is 2, so it is balanced. And then oxygen is 1 plus 2, that is 3. And then here it is 3, carbon is 1 here, and carbon is 1 here. So with this, the equation is balanced. Balancing of a chemical equation has to do with ensuring that the number of atoms on the reacting side is equal to the number of atoms on the product side. So that is what we have done now. You can use another method or another way to do it, but that is what we seek to achieve when we try to balance any given chemical equation. So we have balanced this equation, and we will move further to solving the first question. It says, from a result and the information provided, calculate the concentration of B in mole per dm cube. Remember that concentration in mole per dm cube is also the same as molar concentration. And then we will use the formula CaVa all over CbVb is equal to Na over Nb. The reason is that the number of moles of a substance is equal to the concentration times the volume. So the number of moles for the acid is equal to the concentration of the acid times the volume of the acid. And the number of moles for the base is equal to the concentration of the base times the volume of the base. And so if we express both of them in terms of ratio, we have Na all over Nb will be equal to CaVa over CbVb. So that's how this formula came about. So we have it to be this, and then from what we are given, we know that our Ca, the concentration of our acid, is given already. The question says A is 0.1 mole per dm cube. So we know the molar concentration of A. So we have that our Ca is equal to 0.1 mole per dm cube. And then our Va, the volume of acid used, we have obtained it from the titration done to be 23.42 cm cube, and then the concentration for the base is what we are looking for, the concentration of B in mole per dm cube. So Cb, not really the concentration of the entire base, but the concentration of the base in this reaction, the concentration of B in mole per dm cube. So we have our Cb to be, we are looking for it, and then we have our Vb to be equal to, the volume of the base we are using is 25.0 cm cube, and then we have that the number of moles of the acid. Now when we look at the acid and the base, this thing means that this equation tells us that we need 2 moles of the acid to react with 1 mole of the base, because there is no number here, so we know that it is 1. We look at the ratio of combination of the acid to base is 2:1. So the number of moles for the acid, we will take it to be 2, and the number of moles for the base will take it to be 1. That is as we express them in ratio. So we can substitute, and if we try to make Cb the subject of the formula, we can cross multiply to make Cb the subject of the formula. So CaVa times Nb, CaVa times Nb will be equal to CbVb times Na, CbVb times Na. So at this point we are looking for Cb, so we will divide both sides by Vb Na, so that they can cancel out on the right hand side. So if we divide both sides, it's not really necessary to write in this, divide both sides by, let me take this out, divide both sides by Vb Na, we have that CaVa Nb all over Vb Na is equal to CbVb Na all over Vb Na. Now why we are doing this? We are doing this because we actually want Vb to cancel Vb and Na to cancel Na, so that we have only Cb. So we have that Cb is equal to CaVa Nb all over Vb Na. And if we substitute directly, we'll have this will be equal to, our Ca is 0.1 times our Va is 23.42 times our Nb is 1 all over our Vb is 25 times our Na is 2. So if we do this, we're going to have that Cb, the concentration of B in mole per dm cube, will be equal to 0.0468 mole per dm cube. Now you will notice here that our Va is in cm cube, our Vb is in cm cube, so their units can cancel out. And then our Na and our Nb, they don't have any units because they are just expressions in ratios. So they don't have any unit. So the unit of Cb will be in mole per dm cube. So let me include that here as well, that our Cb is equal to 0.0468 mole per dm cube. mole per dm cube. So we have gotten the concentration of B in mole per dm cube. So I'll take these ones off. We have gotten that. Let me put this one properly, CO2. Now after that, the next question says that we should calculate the concentration of sodium triazocarbonate 4 in B in grams per dm cube. So how do we do that? Look at here, we have our sodium triazocarbonate 4. Before then, I want to draw your attention to something. You will notice that the question says A is 0.1 mole per dm cube of triazonitrate 5 and B is a solution containing 2.5 grams of a mixture. So you have B to be this, and then that B is a mixture. So B has two components in it. B has this and this. So let's say this is our sodium triazocarbonate 4, and then this is our sodium tetraazosulfate 6. So B is a solution containing both of them in 250 cm cube of solution. But you find out that in the reaction, only sodium triazocarbonate 4 is reacting with the acid. And the reason is that sodium tetraazosulfate 6 is a neutral salt, and so it does not take part in the reaction. Please take note. It does not take part in the reaction. Now what we have done is that we have calculated for the concentration of B in mole per dm cube. Now that is in this reaction. That is in this reaction because we use the mole ratio of the acid to base. So we have calculated for the concentration of sodium triazocarbonate 4 in mole per dm cube. Now we come to the concentration of sodium triazocarbonate 4 in B. So we still use that formula. The second question, we have concentration of sodium triazocarbonate 4. Please let me bring this one out again. I'll need you to explain something. And then in B, in grams per dm cube. So this CB that we have calculated, this concentration of the base is actually the concentration of sodium triazocarbonate 4 because it is a compound that is reacting with the acid. So this CB is for sodium triazocarbonate 4. So how do we find the concentration of this same sodium triazocarbonate 4 in grams per dm cube? We use the formula concentration in mole per dm cube is equal to concentration in grams per dm cube all over molar mass. All over molar mass. So this is the formula we use, and by substitution, the concentration of B, that's the base, in mole per dm cube, we have already gotten it to be 0.0468. This is equal to the concentration in grams per dm cube over the molar mass. We have gotten the molar mass from the question that the molar mass of sodium triazocarbonate 4 is 106. So from here we can cross multiply and we will have it that concentration of Na2CO3 in B is equal to 0.0468 times 106. And then when we do that, we're going to have 4.96 grams per dm cube. So we have gotten the mass concentration now. We have gotten the mass concentration in dm cube, in grams per dm cube, and it is 4.96 grams per dm cube. The difference between molar concentration and mass concentration tells you how many grams of that substance is dissolved in 1000 cm cube. Whereas the molar concentration tells you how many moles of that substance is dissolved, and so they do not mean the same thing. So we have it like this, and this is the relationship between both of them. So we have obtained the concentration of sodium triazocarbonate 4 in B. Take note that this is just the concentration of sodium triazocarbonate 4, and that's why the question was specific. It says calculate the concentration of sodium triazocarbonate 4 in B, because in B you have sodium triazocarbonate 4 and you also have sodium tetraoxosulfate 6. So we are done with this. Now the next question is the percentage of sodium triazocarbonate 4 in the mixture. So I will need to take this. Let me write this other one down. The concentration in gram per dm cube of sodium triazocarbonate 4. This will give us 4.96. Let me just leave it there. And then we have, and then now the percentage of this in the mixture. So we know that percentage, number 3 now, number 3, percentage of this will be equal to the mass of Na2CO3 all over the mass of the mixture, because B is a mixture containing this and this, times 100, times 100%. That's how to find the percentage of sodium triazocarbonate 4. But then we do not have their masses directly, and so we can actually look for their mass concentration. This is still equal to the mass concentration of sodium triazocarbonate 4 all over the mass concentration of the entire mixture times 100%. So we can say this is equal to mass concentration of Na2CO3 all over the mass concentration of the mixture times 100%. We can also use this method, this one, or either the mass directly or the mass concentration. They'll still give us the same answer. So we know the mass concentration of sodium triazocarbonate 4, and it has been obtained to be 4.96 grams per dm cube. That's the mass concentration. But we don't know the mass concentration of the mixture. So to find the mass concentration of the mixture, So we look at the question. It says B is a solution containing 2.5 grams of a mixture of this in 250 cm cube. So the mass concentration of the mixture B is what we are looking for. So we say that 250 cm cube of B contains 2.5 grams. Contains 2.50 grams. Therefore, 1000 cm cube. Remember that we want to know the quantity or the mass that will be dissolved in 1 dm cube, and 1 dm cube is equal to 1000 cm cube. So the question tells us that 250 cm cube of B contains 2.50 grams. So if 250 cm cube contains 2.50 grams, how many grams will be contained in 1000 cm cube? That is in 1 dm cube. So we have 1000 cm cube will contain 1000 times 2.50 divided by 250. This is in cm cube, this is in cm cube, and then we will have that this will be equal to 0 can take care of 0, and then we have 2.5 times 100 will give us 2.5 times 100 will give us 2500. Sorry, will give us 250. 250 divided by 25, we have this to be 10 grams per dm cube. 10 grams per dm cube. So what this means is that in 1 dm cube, or in 1000 cm cube, you have 10 grams. So we have it to reduce. So we have known the mass concentration of the entire mixture. This mass concentration is the concentration of both. Remember this, our sodium triazocarbonate 4 is the concentration of sodium triazocarbonate 4 plus the concentration of sodium tetraoxosulfate 6. That is this value that we have. And then we have already obtained the mass concentration of only sodium triazocarbonate 4, and we have obtained it to be 4.96 gram per dm cube. So therefore, we can say that percentage of Na2CO3 in the mixture, let me cut this one out. In the mixture, we can say that to be equal to the mass concentration. Let me write it again. Mass concentration of Na2CO3 all over mass concentration of the mixture times 100%. So this will give us the mass concentration of sodium triazocarbonate 4 is 4.96 divided by 10 times 100%. So 0 can take care of 0 here, and then we have 49.6%. So that is the answer. This is the final answer. So this is how to go about solving this question. I hope you understand each of the steps and you'll be able to attempt a similar question on what we have treated. So please do well to go through the videos, like, and then subscribe to the channel, and also share with your friends to help them understanding this. Don't forget to try your hands on the exercise that you will see at the end of the